Hello everyone, welcome to Code and Learn. So in this lesson, we are going to start using Postgres to store our news data. So let's get started. First, I'm going to create a news package. Inside it, we will have postgres.go package news. Inside the package, we are going to create a connection to Postgres. We will use Bun as our query builder. Bun can also be used as an ORM, but we are only going to use Bun as a query builder because we don't want to deal with the extra complexity that comes with ORMs. So as you can see, Bun wraps SQL DB to provide builders and hooks and create DB operations. So once you have the DB, you can use it to create different queries. Like here, we have a select statement. I will post a link to this in the video description so that you can have a look at the documentation. So inside Postgres, the first thing we will do is create a config that we will use to connect to the DB or Postgres. Type config struct host, which is a string, DB name, the name of the DB, password for the DB, port for the DB connection, debug. It's a bool that indicates if we are running the connection to DB in debug mode. When you enable the debug mode with Bun, you can see the query that Bun is creating to perform different DB operations. Next, I will have max open connections, which indicates how many open connections Bun will have. Similarly, I will create max idle connection, then user that we will use to connect to the DB, then SSL mode. Now I will define a method on config to get the connection string from the config. So func c config connection returns a string. Inside it, we will just return a string fmt printf. So this string is created from the config. Here we will say DB name, then host, port, user, password, and the last one, which is the SSL mode of our connection. Now to inject this value, we will use config. So c.dbname, c.host, c.port, c.user, c.password, and the last one, c.SSL mode. So with this, we are just returning a connection string parsed from our config. Now I will create a constructor function to create a DB instance. So func new DB takes a config and returns either a bun.db or an error. Save it. We should have bun imported into our file. Now we need to run go mod tidy to import it. So let's run make tidy and that should fetch bun. As you can see, we are no longer seeing an error message. Inside it, we will do config error pgx, which is a dialect we are using to connect to the DB. Parse config c.connection or the connection string. Save it. Again, to import pgx, we will run make tidy. And as you can see, we have pgx imported. Now, if error is not is equal to nil, we return an error, nil, error. Then we need to create a SQL DB that we will use to create an instance of bun DB. So we can say SQL DB is equal to stdlib, which is also part of pgx. So I can just copy it here and say stdlib and then open DB, pass the config that we get from here. It is actually a pointer. So this. Now on this SQL DB connection, I will set the max idle connection c.max idle connection. Similarly, we will set the max open connection. So I can do max open connection c.max open connection. Now let's create a bun DB instance from this bun.new DB, pass the SQL DB, and for dialect, we will say pgdialect.new. Now if the debug flag is set, that is c.debug, we are going to add some query hooks that will print the queries that Bun is running to execute the operation. So db.add query hook bun debug.new query hook, and then we supply bun debug.with verbose set to true, and at the end we just return db and nil for the error. So that's it for the DB connection or the bun DB that we create from the Postgres DB connection. Here these packages need to be imported. So let's just run make tidy again. Save it, and now we should see the error are no longer there. So this is how we connect to SQL DB and then create a bun DB from it. Now I'm going to create another file called store.go package news. Here I'm just going to create a wrapper around the bun DB. So I can say type store struct DB, which is of type bun.idb, which is an interface provided by Bun. Then as usual, we will create a constructor function. New store requires bun.idb and then return the instance of store. Inside it, we will just return a pointer to store populated with db. So that's our small wrapper. Now to perform different DB operations, we are going to create methods on the store. First one is to create a news. Then we will have find by ID, find all, then delete by ID, and in the end, update by ID. So these are the 5 different methods we will have to perform the CRUD operations using Postgres. Before we implement these methods, we need to create a model to map the different fields on our table. So here, I'm just going to create a file, record.go. It will hold the model to map the table. Package news. Now let's create type record struct. The first thing we need to do is embed bun.baseModel. This is required when working with Bun. So bun.baseModel, here we are just going to provide the table name for Bun to let Bun know that the table that this is mapped to is called news. Next, we will declare different fields on it. First is the ID of the news, which will be of type UUID, then author, which is a string, title, string again, summary, string, content, string, source, which is again a string, tags, which will be an array of strings. Then we have created at, which is time.time. Similarly, we will have updated at, again time.time, then deleted at, time.time again. So these are all the fields or the columns on our table news. Now we need to provide Bun tags so that Bun is aware of what the relationship these columns have in the table. First, let us create one for ID. So I will say it is mapped to the ID column. It is a primary key. Type is of UUID, where default value will be provided by the UUID generate function in Postgres. So UUID underscore generate v4. Next, we will have one for author. So I will say Bun map to column author. Then I will use the special tag null 0. That is, when a 0 value is provided for this type, that is an empty string, it should be treated null in the table. And then I will say the field is not null in the table. So when you provide an empty string, Bun will convert it to null. But then we are also adding a not null constraint. That means our operation will fail. Similar to this, we will do title. Again, null 0. As these values are required, we will say not null. Forgot to add the quotes here. Next is summary. Again, null 0, not null. Content, null 0, not null. Source, null 0, not null. Similarly, we will have one for tags. Tags, null 0, that is empty array, should be treated as null. But this is a required field, so we will set not null. To let Bun know that this is a array type in the Postgres table, we will say it is a array. Next is created at, again null 0, not null, and default will be current timestamp. I can just copy this here because this is going to be the same for updated at. We just need to update the column name. Next, we can use a similar thing for deleted at, but this time we need to have deleted at. Now we have null 0, but we don't need it to be null. That is, it is not a required field and will only be set when we want the record to be considered as deleted. For this, we will also remove the default and just add soft delete. That is, we are letting Bun know that this record should have soft deletion. That is, when we want the record to be treated as deleted, we will just add a deleted at timestamp. So whichever record has the deleted at timestamp will be considered deleted from the database, but it will still exist in case we want to revive it in the future. So that's the model for it. And we are calling it record to say that it is a table record. Now let's create our methods. First, let us create func store create. It will take a context, then the news we want to create, which is of type record. Then we have created news, which is a return value and will be of type record. So we want to return the created news, then an error. Inside it, first thing that we will do is create a news ID, because we don't want the user to provide the ID, but we want to create it ourselves. So we can do uuid.new, and that should set the news ID on the news that is to be created. Now let us perform the operation to create the news or insert the record into our table. So s.db.newInsert, which is create a new insert statement, then provide the model, which requires a pointer to the model. Here we can just say news and then returning everything. For that we will use asterisk. In the end, to perform this operation, we need to call scan, providing it the context and the pointer to created news. Next, we check if error is not equal to nil, we return the error. So created news and error. If everything works out, we do the same. Here it's complaining because we are creating a new thing, but it already exists, so we just need to assign a value. You may notice that we can directly return this, so we don't need to copy it. But in the future lesson, I will show you how to convert this error to a custom error so that the caller can know what is the actual problem that happened. Similarly, let's do find by ID. So func s store find by ID context, which is of type context.context, takes a ID, which is UUID, returns a news object, which is a record, and an error if there's any error fetching the record from the DB. Now this time we need to create a select statement. So I can say error s.db.newSelect, provide the model, which is appointed to news, then where, which is the where clause, to find the record. We can just say id is equal to question mark and then provide the id, which is id that we get, and then call scan to perform the operation, turn news error, and if there's no error, we again return news and error. Again, this is something I'm doing because I want to check the error type and then return a custom error so that the upstream caller can understand what error happened and then respond to the client with the appropriate status code or HTTP status code. Next, let us code func find all. So s.store find all just needs a context. So here we say news, which is now a slice of records because there could be many. So we can say error is equal to s.db.select or newSelect, provide the model, which is news, and then scan it, provide the context and appointed to news. Similar to what we did earlier, we can just copy paste what we have here and do that. Now let us create the method delete by ID. So func s.store delete by ID. Again, first thing is context, then the ID of news or the record that we want to delete. In this case, we will just return an error if the operation fails. If nothing happens, we just return nil. With the delete query, you get two results. The first one holds the number of records that were affected, but we don't care about it here. So we'll just say s.db.newDelete. Again, model pointer to record so that it can read the model, and then where, which will be the ID of the news we want to delete. So we can say ID is equal to ID and then returning null because we don't care about the return values, and then execute the statement with the exec, passing in the context. Same here, if error not is equal to nil, return the error, and if there's no error, we just do nil. So just to be explicit, let us update this to say null, nil, nil. Now the last one we have is update by ID. So let's do that. Func s.store update by ID. First is the context, then the ID, and then the news that we want to update. It returns the error. Again, we don't care about the return values. If the operation is successful, we just return nil. Again, this returns two values. We will later use them to provide a custom error. So for now, we are just using a underscore to say we are not going to use it. s.db new update model provide pointer to record, or the, in our case, news, where ID is equal to the ID that was provided to us, returning null, and then exec. Copy the same thing here and do this. So these are all the methods that we are going to have on the store. Just to recap, what we did was in Postgres, we created a config that maps to the Postgres database config. Then from the config, we parse a connection string that we use, create a config or PGX connection string. Then we create a SQL DB from it, set some values, and finally we create a Bun DB wrapper from that SQL DB, returning the DB. And if we have the debug hook enabled, we print the queries in a verbose mode. Then we created a record by embedding bun.base model, adding our fields, then providing the bun tags so that Bun understands how we have configured the table. Then in store, we create a wrapper around the Bun DB, performing different operations using Bun. We have the insert statement, select statement, then delete and update. So that's it for this lesson. In the next lesson, we will create custom errors so that we can let the caller know what will be the appropriate HTTP status for the failure. That's it for this lesson. If you have any questions, please feel free to comment under the video or reach out to our Discord server. Until next time, happy coding.